Right. So those of you who do not have any requirement to be on the meeting can also go and watch it on YouTube live. I will share the link very soon on the chat window and also if possible on the WhatsApp window. So that is the I share the link on YouTube. So you have an option of watching on YouTube or watching on the meeting. But obviously, if you are a presenter, you have to be here, not on YouTube. Okay. Right, there we go. So, timekeeper, are you there?
Yes, sir.
Sachin, you are going to read today the timing, right? So
Yes,
remember,
sir.
after 3.5 minutes, you have to say loudly 30 seconds remaining, and the speaker will say Roger. And
Okay,
then
sir.
at the end of 4 minutes, you have to say time up, please stop speaking. And the user has to say Roger. Okay?
Okay, sir.
And Aashman has a nice message for everybody. Please spend minimum time on the introductions, pilot name, flight number, date of the accident, and other things, so that maximum can be given to the main causes and also the lessons learned, may I add. So I'm going to share the screen. First, I want a confirmation from Avijit that he is able to see my screen in after 2 seconds or so.
Yes, sir, I can see the screen.
The moment you start speaking, immediately Sachin is going to start his clock. Okay? Right. So we can start whenever you are free.
I'll start now, sir.
Yeah.
Good morning, everyone. On behalf of Team 5, I, Commodore Sagar Vijay Shukla, would be presenting the air crash investigation of Cathay Pacific Airlines 780 at Hong Kong International Airport. Next slide. The presentation is divided into the following subheadings, wherein we would focus more on the analysis and the changes that took place after this incident. Next slide. Flashed on the screen are the flight details, wherein the flight landed at Hong Kong Airport with both engine malfunction. Next slide. Let us look into the timeline of the events. After 34 minutes of takeoff, the crew received a message of engine 2 control system fault and engine 2 slow response. The crew immediately referred to quick reference handbook, which says that they need to avoid rapid thrust changes. They also contact the operations control center, wherein the maintenance engineer told them to do the same. At 0521 hours, the engine 1 stall warning flashed and the crew declared pan sign to ATC. Thereafter, the engine lost thrust control and was struck at 74% RPM and 71% RPM. Emergency changed into Mayday call and aircraft landed with 170% of the normal touchdown speed. Next slide. Being a case of faulty engine response, the first thing that was checked was the fuel system. It was found to be contaminated at various locations indicated by the red markings in the figure by a particle called sap sphere. These jammed the fuel metering valve and hence there was no response by the throttle movement by or any governor. Next slide. The contaminant, that is sap sphere, is a product of super absorbent polymer used for restricting water molecules entering the aircraft while refueling. Its working can be shown with the help of the figure. Here, the water present in the fuel is shown by the blue color. As they pass through the filter, the sap turns them into gel and they get restricted into the filter and clean fuel goes inside the aircraft. Next slide. The situation changes once you have salt content in water. With salt in the water, the gel could penetrate through filter, forming spheres of varying sizes and can reach various parts of the aircraft fuel system. Next slide. It was also found out that the hydrant refueling facility was recently extended at Surabaya Airport, due to which there was high possibility of salt water mixing in the fuel. Further, the refueling operator noticed some vibration during refueling. However, after confirming the fuel quality check of the dispenser, it was not reported, assuming the cause to be air bubbles. Next slide. From the analysis, it was evident that the primary cause of the accident was the accumulation of sap sphere in the fuel system due to salt water. The reason of salt water entering the fuel are presence of salt water in hydrant refueling circuit due to lapses during the extension work. The rate of refueling was low, not as per the latest guidelines, due to which the differential pressure limits could not be monitored properly. It further led to the lapses in proper replacement and maintenance schedules of the fuel filter. Next slide. Coming to the developments in aviation industry that took place because of this accident. The first thing was the airline and the Airbus introduced new quick reference handbook wherein similar issues in engine will also flash suspected engine fuel system contamination so that the pilots know the severity of the incident. The ICAO introduced a fresh manual on oversight and fuel quality control on fuel supply to be incorporated across all airports of the in the globe. It also suggested for a differential pressure measuring device that will itself warn the operator when the differential pressure is higher than the prescribed limits. Towards airport emergency handling, the International Civil Aviation Organization also introduced guidelines that the local standby and full emergency declaration will be given as per the information presented by the pilots. Next slide. To conclude, going through the investigation, we found out that strict quality control on the fuel is to be observed.
30 seconds left.
Roger. The fuel supplier and the airports are to be updated with the latest guidelines issued, and any observation which is beyond normal experience is to be brought out to the appropriate authority well in time in order to detect fault before it leads to accident or incident. Here are references, and we are done with our presentation and open for any question that you may have.
Thank you so much for adhering to the time limits. Sachin, very good for giving a timely warning. Aashman, if you are ready, let us start the questions. We are very much in time. Okay, I think there is some issue with Aashman because he is trying to call me. Anyway, let me just take the call. Okay, I'll just take this call and I'll see what I can do about it. In the meantime, please stand.
Hello.
Yes, hello.
Sir, I had got disconnected in between.
Yeah, so you were not able to hear anything?
No, I was able to hear about 3/4 of the presentation and I have my questions ready.
Okay, go ahead then, no problem.
All right. So, if you could please present that slide again, I want to ask a question from the slide.
Sure. I will present the slide again.
Yeah.
If you have a specific slide number, please tell me, or I will just go back.
Yeah, I'll tell you. The sequence of events, the slide that shows the sequence of events. Yeah, this one. So, my question is that between 0521 hours and 0544 hours. So at 0521 hours, there is a pan message for the engine stalling, and at 0544 hours, the engines are at 74%. So, what happened between this time, which led to the engine power going from stall condition to increasing extremely to such a condition where it was not safe for a normal landing to happen? What caused this condition?
I'm Yashwant. I'm answering the question.
Yes, Yashwant, go ahead.
What happened is when the engine was stalled, so the operating procedure was to set that to the idle condition, and so both the engine 2 and engine were in stall. So both were placed in the idle thrust condition, and then the pilot was trying to check if the thrust was responding to the thrust lever. So he was adjusting both the levers to check if it is changing or not. And during that process, while adjusting the thrust levers, the engine 1 thrust changed to 71% and it stayed there. But the engine 2 has never changed and it stayed at 17%.
But what you said should not have happened because the main metering valve was jammed because of the super absorbent polymers. How did that?
So before that, it was showing very high resistance to movement, and when it got stuck at 74%. It was completely jammed. Before that, it was moving, but it was taking a lot of energy to move.
All right. And could you please just go over the improvements that have been suggested in order to prevent such crashes? Actually I missed that part due to being disconnected.
Okay. I'll go ahead.
Yeah.
Causes, development. So this is the, I think this is the one.
All
Yeah.
right. Yeah.
So the fuel guidelines were improved. So generally, the fuel management and auditing was done in the individual airports, and the guidelines were left to themselves. But after this accident happened, the ICAO, International Civil Aviation Organization, set some guidelines on the fuel management and auditing, and all the airports around the world were supposed to follow it. And then in the quick reference handbook of the Airbus, the reason for engine ECAM message, engine 2's control system fault. So the reasons for that message appearing could be there could be a contamination of the fuel. So they added this point into their quick reference handbook so that if it happens next time, they can just turn around and land in the airport. And yeah, so what happened? And the third one is the pilots were talking with the integrated operations control of Cathay Pacific Airways, and they're also talking with the air traffic controller at Hong Kong. So when they called Mayday situation, double stall situation, the Hong Kong ATC was supposed to change the condition from local standby to full emergency, but they didn't do it because they went back to the integrated operation control and asked them about the condition of the aircraft, and the condition of aircraft was not updated in real time to the IOC. So so the IOC didn't know about the double stall situation. So the ATC went with the information given to them by the IOC, and they left it at standby instead of upgrading the situation to emergency. So if they had asked the pilot, if they had trusted, I mean, they took
All
the
right. Yeah,
information.
I get it. I get your point. Thank you.
Okay. Can we go ahead then?
Yeah, sure.
Okay. So the next would be team number 10. On the chat window. Yeah. Okay. Team number 10. Who is the speaker?
Yes, sir. Vishnu here. Am I audible?
Vishnu Shankar, absolutely audible. No problem. Give me a minute. I will
sir, sure.
open the presentation of team number 10. Which is the accident you're going to speak on?
Sir, on the hijacking attempt of flight 219. The
Hijacking
first
attempt.
slide.
Oh, the first one. Okay, very good. The first
Yes,
one.
sir. Yeah.
Very nice. That makes my job little bit easy. Not much, but little bit easy. That is the one. I hope you're able to see this.
Yes, sir. Perfect.
Right. So there are 70 participants in the meeting, whereas we have 108 students in the class. So looks like some of the people who have already presented or how some groups have decided not to come today, they don't realize that it is important for them, but that's okay. That's their choice. We don't want to force anything on us. So if all is well, then let us start. Sachin, are you ready?
Yes, sir.
Okay. So the accident is flight 219. Okay. Right.
Yes, so I'll
go
start
ahead.
now.
Yes, please start.
Yes, sir. Good morning, everyone. I am Vishnu. On behalf of Team 10, I'll be presenting the case study of the flight hijacking attempt. Next slide.
1 minute. I realize 1 minute is too much here.
So these are the contents, and we'll quickly go through each of them. Next slide, please. So 1970, the El Al flight was headed from Israel to New York with a stopover at Amsterdam, where two hijackers disguised as married couples boarded the aircraft.
Next.
Yes, slide.
1 minute. Ah.
Yeah. So roughly 30 minutes after the flight took off from Amsterdam, the hackers revealed their identity and threatened to blow the aircraft. At this point, the pilot puts the nose into a negative G dive, and then the hijackers were stopped by the marshals, which we'll quickly look next. So next slide, please. Yeah, again, next slide, sir. So all these incidents happened within just 2.5 minutes. Next slide, please. So when The inertial loads act against the G force. The aircraft experiences a negative G load. Next slide. So let's say you are in a falling elevator. Basically, you are floating inside it. Similarly, pilot puts the nose in a negative G dive. All the hijackers who were standing started floating. Next slide, please. Now imagine someone catches the falling elevator. Since you are floating inside, you will normally fall on the floor of the elevator. Next slide. Similarly, when the pilot pulls out the aircraft from the negative G dive, the hijackers who were floating fell on the floor. Nothing happened to passengers because they were all seated. The marshal who was inside the cockpit comes out and shoots the hijackers and the hijacking. Next slide. So this is Boeing 7458. The aircraft could withstand more structural loads. So the pilot knew how much time he could keep the aircraft in a negative G dive. Next slide. So this is the VN diagram. Y-axis is load and x-axis is indicated airspeed. The green region is safe operating zone. Orange and red regions can cause more structural damage. Now you can see that this is the negative region where the aircraft was when the pilot had put it in the negative G dive. Observe that the aircrafts are generally not made to withstand high negative G load. Two reasons. One is it adds more weight because of structural integrity. Another reason is due to a biological reason called the redout. Next slide, please. So from engineer's perspective, how can the aircraft more hijack proof? So Honeywell came up with the assisted recovery system, which detects danger and automatically takes away the control from the pilot. Can install secret cockpit escape doors, which is only known to the pilots. A panic button can be installed in the cockpit. So when the pilot presses it, the door is automatically jammed and threat notification will be sent to the nearest ATC. Sleep switch can be installed in the cockpit. So if it is pressed, gas will be released in the passenger cabin and the hijackers Roger. And the hijackers and passengers will doze off. Another idea is to divide the aircraft into 3 sections using reinforced doors. Next slide, please. So the reinforced doors are bulletproof and only one door can be opened at a time. Any unauthorized person who comes will be trapped inside the crew section. So even in flight, the pilots knew the capability of reinforced cockpit doors and are not afraid
Time's
of
up.
executing their
Time's up, please
mission.
stop.
Yeah, next slide.
Time's up, please stop.
Yes, sir. Next slide. That's all, the conclusion. Yeah, so ultimately we would like to quote the Martin Luther King's.
Hello.
Right.
Yeah.
Very good. Questions can start. We have just barely managed to fit in the time. It's okay. Go ahead.
Okay,
Aashman,
so
go ahead.
I'll start with my questions. First is so there were 2 reasons why the captain decided that he would throw the plane into the dive. One reason which you covered was that he wanted to induce negative G force in order to throw the terrorists off balance. What was the second reason that he considered? And let me give you a hint that when the hijacking happened, the plane was, if I'm not wrong, it was between 25 to 30,000 feet in altitude. So that's kind of a hint for the second reason why the pilot considered to throw the plane into a dive.
Anybody can answer from the team, not necessarily the speaker.
All right, I'll go ahead and provide one more hint to that. It's related to the captain's knowledge of the kind of firearms carried by the hijackers. So
Okay, that's a very good hint. That's a very good hint.
if you could connect the dots, and you'll be able to find out the answer. You can
Sir,
try.
I'd like to answer this question, sir.
Go ahead. Go ahead.
So this hijacking was a part of Dawson Field's hijacking plan, in which a total of 5 aircrafts were hijacked, and the hijackers were from Palestine Liberation Army from Israel, and they have a certain modulus operandi in which they operate, sir. So the firearms which they carry were mostly grenades in which they would blow up the aircraft. So the second reason which was inducted by pilot to put it in a negative G, that even if they were having a hand grenade in a head, so the moment they will go into a negative G and come back, that will cause them to disbalance off and they will not be able to throw the grenades. This is what also actually happened. like one of the terrorists tried to throw a grenade, but because of this induction of negative G, he was not able to launch it properly, and it was a misfire. And that terrorist was eventually subdued with the help of passengers, sir.
Okay.
All right,
Aashman?
that was a good attempt, but it's not exactly to the point. Anyways, I'll move on to
Never
the
mind.
next question.
Yeah.
So also in the presentation, at some point it was mentioned that one of the flight attendants or the passengers, like somebody was injured in the brawl that was that followed in order to subdue the terrorists. So the captain Uribalev, he decided to make an emergency landing at London in order to save the life of his flight attendant. Despite he took that decision despite orders from the top Israeli authorities to go to Tel Aviv. So my question is that why did the Israeli authorities order Captain Uri Bar-Lev to come to Tel Aviv despite having the knowledge that there is somebody on the plane who could lose their life?
Okay, so the terrorists, like those who were, they were from the Israeli descent, and their demands were like to carry to like they demanded to like a release of Israeli terrorists from the prisons of Israel and Tel Aviv. But Uri Balev, as he was the captain of the aircraft and control in charge, he decided to save the life of the person and landed in Britain. The Israeli authorities asked him to come back to Tel Aviv so that the extraction process of those terrorists could be easier. But Uri Balev went with his gut feeling, and he decided to go against the authority because as a captain, it was his responsibility to save the passenger on the aircraft.
I do get your point, but I would like to slightly modify the question.
Aashman, listen. Like just like the speaker, we also have only 4 minutes for the questions.
Okay.
Sachin, keep a track on the on the questions also, please.
Okay.
Okay. I think we should go ahead. I don't think we should ask the question because otherwise, I'm sorry, but we will not be able to meet our time. And I know today I have something very urgent happening at 11 o'clock, and I want to finish this before 11 o'clock.
All right. All right.
So it's okay. You have asked them 2 questions. They were not able to answer one of them. That's fine. Okay. Right. Now we go to the next team. The next team is going to be team number 4. So team number 4, I'm going to share your presentation. Okay. Are you ready? Number 4?
Yes, sir. The first slide itself.
So who is the speaker? Vedit, ready?
Yes, sir. Vedit. Yeah.
Okay. 1 minute. Crash of Turkish airline flight. That is the one?
Yes, sir. Yes, sir.
Okay. Turkish airline flight 1951. Okay. So, right.
Sir, the first line, the first slide itself.
I know. I'm having some issue in sharing the slides, which is now okay. Right. So,
yeah, I can see the slides now.
Yes. Right. Go ahead.
Sir, I still can't see the slide. Second, please.
Can you see it?
Yeah. Now it's okay.
Okay. So
Can I start?
Yes, start. Once you start, 4 minutes timer will start.
Okay, sir. Hello, everyone. I'm Vedit. I'm going to present the second crash assigned to Team 4. Crash of Turkish airline flight 1951, and it's a Boeing 737 model. Next, sir. This is the agenda of the presentation. Next, sir. The flight path was from Istanbul to Amsterdam airport. Next, sir. Let's see how this happened. Next, sir. This is the glimpse of the accident site. Next, sir. And this is the closer look at it. Next, sir. The crash took place about 1.5 kilometers from the runway. Next, sir. Briefing about the sequence of events. During the arrival, due to faulty left altimeter reading of -8 feet, one of the 2 on board, auto throttle shifted to retard flame mode, leading to idling of both engines. Plane crashed tail first into the ground soon after. Next, sir. Let's get into the technical part of the accident and have a closer look at the cause. Radio altimeter. Radio altimeter works on the Doppler effect. It has a radar that sends and receives the counter signal. It measures the altitude through given equation. Next, sir. Looking at the block diagram of radar, We suspect duplexer could have been damaged and sent transmitted signal right into the receiver, which could have been the reason behind the faulty reading. Next, sir. Instrument landing system. It consists of two components, localizer for horizontal adjustments and glide slope for the vertical adjustments. Next, sir. Markers shown here provide guidance for the runway to the approach. Next, sir. Glide slope and horizontal alignment procedure took place way late than it should have been. This already indicates the trouble. Next, sir. Autopilot. Autopilot is a system used to control the trajectory of an aircraft without requiring constant manual control. In the flight, right side autopilot was engaged, being flown by co-pilot. Next, sir. Auto throttle is a system which controls fuel input to maintain the speed of the aircraft. On Boeing 737, in principle, the auto throttle uses the altitude measurements provided by the left radio altimeter. Unless problem recognized, they won't change to right. Next, sir. What went wrong? Auto throttle due to faulty altimeter reading shifted to retard flare mode. Next, sir. Further, at about 1,000 feet from the ground, auto throttle started killing thrust. But autopilot, recognizing requirement of lift, started to nose up the plane as retard flare mode conditions were met well before landing. Next, sir. At about 350 feet from the ground, stick shaker activated, which is a safety device which indicates stalling. As soon as pilot recognized stall warning, he pushed the throttle levers to full, taking manual control. But altitude wasn't enough and the flight crashed. Next, sir. Remedial actions taken are the reliability of radio altimeter system was questioned and multi-sensor fusion was proposed. Pilot training regime was updated. So yeah, pilot training regime was updated, bringing in procedures involving stalling. Instruction manual was updated, including instructions on faulty radio altimeter readings in the flight. Next, sir. Now, whom to blame for? The ground crew or the pilots for being late on the landing checklist? Boeing for not intimating crew regarding faulty radio altimeters, although there were 6 to 7 instances as this before, but there were no crashes. Or the FAA for allowing aircraft without proper checks. Next, sir. This concludes the presentation from the team 4, and thank you. Time for questions.
Okay, thank you. Sachin, you can reset your clock to 4 minutes. And Aashman, you can start the question. One minute, please. Aashman, are you able to speak? Okay, there seems to be some problem with Aashman. So give me a few minutes. I'll see the chat window. Okay. Aashman is asking me in chat window to ask some questions. Okay, so the question that he wants to know is, what do you mean by the retard flare mode? Can you explain the meaning of retard flare mode?
Sir, shall I take this question, sir? I'm
Yes,
Mohit Walia, sir. Retard flare mode is a mode in the autopilot which gets activated when the aircraft reaches at a height of 50 feet above the ground and it is just about to touch down. So radio altimeter is reading a value of -8 feet, which means that autopilot is and auto throttle both are switched on. So they are assuming that they are just about to land, and that is why this accident has happened, despite the aircraft was at a height of 2,000 feet.
Okay, so that is what it is. Okay.
Sure.
Right. The pilots were aware of the problem of the faulty altimeter because they had corrected it twice before, right? Yet,
No,
why
sir,
were they
the
not able
pilots
to? Let me finish my question, please.
Okay, okay, sir.
Okay, the pilots were aware of the problem of faulty altimeter because they tried to correct it. They had corrected it twice before. Yet they were not able to save the plane. Why is that so?
Sir, I would like to take on this question too, sir. There was a one indication which has come at a height of 2,500 feet that the landing gear is not down. So they got the audio warning and it was just went away, sir. Because the radio altimeter is not faulty, sir. The term should be you should use here is a intermittency, because the aircraft has such flown for 3 hours and it was just about to land for the final approach. So it is intermittent. And while undertaking the landing, we have to understand this aircraft is under supervision sortie by the captain, and the actual person in command is a co-pilot because he is going to fly for the main controls. So while it has been observed that initially the warning has come, but that has been neglected by the pilot, saying that it may be one odd intermittency. And that's why when they're undertaking the landing checks while making the approach and maintaining the glide scope, and by the time they have realized that it is taking a feed from the wrong altimeter, it was too late for them to come back from that situation. Sir. Thank you.
Okay. Next question I have is, why did the crew align the glide slope later than they should have done?
Sir, the glide scope in a normal approaches has to be come from the below the glide scope, but in this particular case, as I mentioned, that it's a sortie under supervision. So unfortunately, here the pilot is coming above the glide scope, and that's why they are taking time to maintain that glide scope and could not pay attention parallelly to the altimeter. And the aircraft was on autopilot and auto throttle. So this was the another remedial action which Boeing has taken up after this particular accident, that we need to avoid using autopilot and auto throttle while at the time of landing. So this was the advisory which was issued mainly after this accident.
Okay. All right. Good.
I'm back here. So were the 3 questions asked?
Yes, all 3 were asked and all 3 were answered. No problem.
I'll have a look at it in the recording. Thank you.
Yeah. It's there in the recording anyway.
Yeah.
Right. Let's go ahead with the team number 8. Team number 8. Team number 8, are you ready?
Team number 8, are you ready? Hello, I'm sorry, I'm not able to hear. Team number 8, are you ready?
Yes, sir.
So I can see it is Venkat Krishnan.
Yes, sir. You meant team number 8, right?
Yeah. Which accident will you talk about?
The West Caribbean Airways Flight 708.
So that is the second accident.
Right.
West Caribbean Airways flight 708. Venkat
Yes,
Krishnan. Okay. Fine. So we are going to go to team number 8 now. So I am just going to share your screen in a minute. There we go. Screen is visible?
Yes, sir.
Right. Okay. Fine. So if it is visible, then Sachin, are you ready?
Yes, sir.
Okay, start team number 8.
Hello, everyone, and a very good morning to all of you. Our group will be discussing about the crash of the West Caribbean Airways Flight 708, which occurred on 16th of August 2005. Next slide. Yeah. So giving a brief introduction about the crash details, the airplane involved in the crash was the McDonnell Douglas MD-80. The flight was planned to depart from Turkish International Airport in Panama City and arrive at Martinique, Fort de France, and everyone on board had lost their lives. Next slide. So after 27 minutes from takeoff, the plane reached FL310 or flight level 310. 8 minutes later, the pilot requested for a new altitude to the ATC to avoid the line of storms ahead. So the airplane began its normal climb after a few minutes and reached FL330. The autopilot had raised the angle of attack to maintain lift, resulting in reduction in engine power and hence decreasing thrust. Before the ATC could respond to the pilot's request to decrease altitude, the aircraft already stalled and crashed belly first. Next slide. So this is the de-icing and the rain protection system of the MD-80. In flight, de-icing is done with the help of bleed air from the compressor stage, which is around a temperature of 500 Kelvin. It is supplied to the various components of the aircraft such as the cabin, wing, tail parts, etc. Next slide. So after attaining FL310, anti-icing was switched off and autopilot was switched on. At FL330, the crew again switched on the de-icing system. It drew bleed air from both engines, which reduced the thrust, but the MD-80 can maintain its anti-icing system at its max flight level, that is FL319. After realizing the reduction in thrust, captain started rapid descent, but unfortunately the aircraft was already in installed condition. Next slide. So to compensate this, the autopilot had already nosed up by 5.8 degrees to maintain the altitude. So pilots later switched off the autopilot. During this stalling, a sudden turbulence formed above the aircraft, which reduced the air intake in the engines, resulting in excess power drop. So the captain, being unaware of the situation, thought the engines flamed out and also didn't recognize the stall situation. So within 3 minutes, the aircraft crashed to the ground. Next slide. So this is the flight crash site in the borders of Venezuela and Colombia. And now I hand over to Jagriti.
Next slide, please. Now, moving on with the causes, investigators found that the human error was the major factor. With the anti-ice system on, the aircraft could fly at a maximum altitude of FL319 without stalling, but the aircraft was flown too high with respect to its weight and weather conditions. Meteorological aspects were neglected in the flight plan before the takeoff. There was also a lack of situational awareness and poor decision making, such as believing that there was some issue with the engine and hence the captain worsened the stall by increasing nose-up attitude. Additionally, the airlines did not share the operation bulletin received from the manufacturer with the pilots. Besides, the airlines were under financial debts and had suspended pilots' paycheck for 6 months, which could have affected their psycho-emotional state. Next slide, please. The official report of the investigation provided a long list of recommendations to ensure that such a tragedy never repeats. It concludes that there was insufficient situational awareness in both the pilots. Hence, the Colombian aviation authorities were recommended to improve pilot training, specifically the communication and understanding the autopilot system, while the manufacturers were recommended to improve flight data recorders and developing algorithms for alerting crew and also to provide rapid
30 seconds
suggestive
left.
actions. Roger that. After this incident, the airline was grounded forever, but West Caribbean Airways left behind a valuable lesson, better safety measures for every MD-80 taking to the skies today. Next slide, please. That's all from our side, and thanks for your patience. Now we are open for any questions.
Very nice presentation. Very good coordination between the two speakers. I really liked it. Aashman, over to you.
Yeah. So you mentioned that the maximum altitude for the anti-icing to be on should have been flight level 319, right? That is 31,900 feet. So the pilot should have known this. He should not have gone beyond 31,900 feet in altitude. Why did he choose to go all why did he allow the plane to go beyond that altitude?
Good morning, sir. There's call leader Salil. I'd like to answer this.
Yeah, okay.
So
Salil. So there was somebody else also who was trying to speak. It's okay. Between two of you, you can decide. I have no problem. Since you have, who was the other person who wanted to answer? Just wanted to know.
Sir, I was about to answer. It's fine if Salil is.
Yeah, Salil can go ahead. Salil can.
Okay, sorry for interrupting, sir. So the aircraft was designed to anti-icing was designed to function correctly till FL319, but as you have brought out correctly, that aircraft was flown at FL330 and anti-icing was switched on. So it clearly shows that pilot was not aware of the capabilities of the aircraft. So that's why they had actually switched on the anti-icing system at such a high altitude. So it was a wrong decision at pilot's part.
Does the second person who wanted to answer want to add anything to this?
Yes, sir. Also, the thing was, when the flight plan was filed, the flight plan stated that the cruise altitude they will be flying at was FL350, and the pilots were unaware, and still the flight plan was approved. So it was actually a human factor which was involved in this, the reason.
All right, I'll take that. Another question I want to ask is, each and every pilot is provided proper stall training to handle a stall. So why were these two pilots not able to recover from this kind of stall? What were the factors that led to the crash after the plane stalled?
May I? I'll try. I like to answer this question.
Yeah, go ahead.
Actually, this stall is actually the basic training which ever pilot is given, like the first training. So in this accident also, the clear indication of stall were there. Stall audio was there. Stick shaker was there. But the actions by the pilot were, they had pulled the throttle back towards their chest. So it was really wrong. They should have put the stick forward and should have increased the speed in order to recover the aircraft. They didn't do it. And the reason was that though the first officer, who was the junior, is 21-year-old pilot, he tried to warn the captain that there was a stall and we should do something about it. But the captain was in a state of target fixation in which he was only thinking about one thing, that the engine has flamed out. So captain did not take any corrective action to recover the aircraft from stall, and he was just thinking about the flame out. And then first officer also was not able to counter the captain because of the large difference between their service, and that's why no one out of them took the correct decision of bringing the aircraft out of stall, and
All right,
the aircraft sadly crashed.
It's fine. And one last question is that what valuable lesson do you learn from the way West Caribbean Airlines management treated the staff and their pilots? So what should be done or what should not be done by an airline?
So this crash is a classic example of why welfare of the employees should be taken into account. In this case, the people were not paid, not just the pilots. They were not paid for 6 months. Even they had 4 similar aircraft. All the rest 3 were grounded. Reason being that they need maintenance, and none of the company didn't have the funds to do the maintenance also. And this flight, where from wherever it was taking off at that time, at that airport also, it was it kept standing for 2 hours because cost of fuel was not paid to the authorities. So because of all these factors, they had this thing in mind, maybe once the aircraft lands, the company will go bankrupt and they won't be getting any pay. So the captain actually had started a restaurant in order to meet his expenses. So the time at which he should be resting, he was working there. So because company was not able to take care of its employees, they had to do some other ventures to meet their expenses, and that's why maybe that psychological effect played a major part in this accident. So so all these factors also played a major role.
All right. So summarizing what you said, that the flight crew was pretty stressed and they made a few wrong decisions, or they did not take a few correct decisions because of stress, right?
Actually, they didn't. Yes, they didn't. So stress played a major role in this accident.
All right. That's it.
Okay, so let's move on. Thank you so much. This is a very sad story of an airline which is almost bankrupt, pilots and the crew who are not paid for 6 months, and stress accumulation because of personal reasons leading to the crash and so much of damage. Right, now we go to team number 7. Team number 7, are you there?
Yes, sir.
Who will going to present?
Sir, Dhruv and Sania.
Dhruv and Sania, okay. Which accident is it, TAM or LL? I think it is TAM.
TAM, sir.
Okay, right. Fine. So,
Sir,
yeah, let us make it full screen.
yes, slide number 3, sir. On.
Yeah. Okay. Yeah, so go ahead. Dhruv, go ahead.
Yes, sir. So, good morning, everyone. Aviation is a branch of engineering that is least forgiving of its mistake. Keeping this as a precursor, let's begin our presentation of TM3054 crash. Next, sir. Next, sir. Our presentation will be covered under the following heads. Yes, sir. Can you please play the video? So, this is a animated video of the flight path. can see the flight lands on the runway. The left reverser is activated. The flight isn't stopping. Eventually, it steers towards the left and it crashes into the building. Next, sir. Now let's dive into the timeline of the day and look what happened. So there are two critical moments. The first is 1719 when the right engine reverser was unserviceable, and second at 1848-24 when thrust levelers were positioned incorrectly. Right throttle was to CL instead of idle, due to which the flight began to steer towards left and hit the TEM Express building. Next. This is the animated flight path. You can see it steers towards the left and eventually hits the TEM Express building. Next, sir. Over to Sania.
Thank you, Dhruv. As we know that any consequence is a cumulative effect of a number of actions incorrectly performed. The prime error here was the incorrect positioning of the thrust lever. Working under extreme stress, the pilot selected an outdated landing procedure in which he set one throttle lever at maximum reverse position and the other throttle at the maximum climb position. Next, please. This can be understood from the thrust lever diagram shown here. According to the whole landing procedure, for an unserviceable thrust reversal, the throttle lever should have been at the idle position marked by the green arrow, but erroneously the pilot set the right thrust reversal to the CL position marked by the red arrow on the diagram. This incorrect lever positions led to the veering off of the plane towards the left. Thrust lever being at the CL led to the ineffectiveness of the spoiler and eventually the failure of the brakes. Next, please. Unfortunately, the plane had to land on one of the most notorious runways in the world, that is runway 35L, which is infamous for its difficult terrain, shorter runway, and the low friction coefficient. The other factor here was the occurrence of hydroplaning at the time of landing. This reduced the retarding force on the landing gear, thereby contributing to the overshoot of the aircraft from the runway. This could have been avoided by proper grooving of the runway, although this factor is debatable, but it was a potential contributor here. Next, please. So who was at fault? Basically, the TAM Airlines refused to incorporate the alarming system that could warn the pilot regarding the incorrect throttle positions. Also, the right thrust reversal was inoperative and hence locked right from the takeoff, which although is permitted but could have been avoided by proper maintenance. Next, please. Moving to the aftermath of this incident, this was an eye-opener to the airlines and the airport authorities for rectifying their ignorance and reluctant attitude towards maintenance. Next, please. Let's see what lessons were learned. One should always learn from the mistakes. This particular accident taught that one should strictly stick back to the standard procedures approved without any bias in almost every situation. Had the thrust reversal been positioned correctly, the crash could have been avoided. There is no place for ignorance and mistakes in the aviation industry. Each and every particular aspect, be it the runway, is as important as the aircraft itself. So proper and sound maintenance should be performed on a regular basis. Moreover, all the modifications announced must be incorporated as they are always for the betterment of
30 seconds left.
Roger. Next, please. That's all about the case study of the TAM Airlines Flight 3054 air crash from Group 7. Now we are open for questions. Thank you.
All right. So the first question I want to ask you is, I'm audible, right?
Yeah, absolutely audible.
So my first question is that the captain of TAM 3054, you mentioned that he performed an outdated procedure. So there must be a new procedure, right? According to what I know, the captain knew or he had received training for both the procedures, the old procedure as well as the new procedure. So why did he decide to choose the outdated procedure, despite the fact that he knew the new and the better procedure to land?
Solid Valodi, this side, I would like to answer.
Go ahead.
Owing to the aircraft limitation, wherein one of the thrust reversers was unserviceable, and also knowing the present condition of the airport because of the local conditions of rain, there was a problem. So what the pilot decided was he will go for a manual approach and will like to use the entire runway. And in order to do that, he decided that maybe if he could touch down a bit early, that would give him some leeway while landing. In order to do that, the old landing procedure which was being prescribed by the airlines was much more effective, as during the landing it would have saved him about maybe 50 to 60 meters of the runway.
All
No,
right.
the question is that the pilot was trained on both the procedures, and still, why did he use the wrong procedure? I think that is the question, correct?
Yeah. So, do you want me to move to the next question?
No, no,
Sir,
no.
can I answer
Exactly,
this
that is
question?
because
Hello, sir. Sir, I want to. Sir, actually, TAMAIR after the during the investigation, the investigating agency investigated the different pilots about the same what they did about the same accident. The different pilots told about 5 different procedures about the same accident or same happening. So it shows that TAM Airlines did not introduce the procedure correctly to their pilots. So after this accident, TAM Airlines introduced means modified their training this thing. So that's why the pilot was not that much was not trained properly by TAM Airlines.
Okay, fine. I'll take that answer and then move on to the next question. Would you like to comment anything about the condition of the runway at Kongonas Airport, given that it had been resurfaced about just a month ago?
And also, was that a factor in the accident?
Yeah. So how like to what extent it was a factor in the accident?
Sir, it has a great influence on the accident. The runway was short, and there was aqua planning, and also the lighting condition was not proper on the airport, and the grooving was not done. Grooving was not done. And when the ATC controller told the co-pilot about this condition just 5 minutes before the landing, and co-pilot told this to pilot, so pilot became he became bit panic about this condition. So maybe that thing also haunted his mind in order to take the correct decisions.
Okay.
All right, that's it from my part.
All right. Thank you so much. We will move on to team number 3. Team number 3, you are next. Is the speaker ready?
Yes, sir.
Team number 3, give me a minute, please. Yeah, 1 minute. I see that. Yeah. Team number 3. I see MS Kumar is ready. Right? Yeah, 1 minute.
Is this the AirAsia crash?
Yes, sir. AirAsia QZ850.
All right, bring it on.
1 minute. I like the way Aashman is saying, bring it down. It's interesting. Okay, so right, AirAsia crash. Okay, so who's going to present it?
Sir, Major M. Surendra Kumar on the side, sir.
Okay, Major Surendra Kumar, go ahead.
Good morning, sir, and good morning to all. Our presentation on the crash investigation of AirAsia flight is based on Indonesia's National Transportation Safety Committee's final investigation report. Next slide, please. I'll be covering the presentation under the heads as shown. Next slide, please. The flight took off from Surabaya, Indonesia for Singapore at the scheduled time. The pilot in command acted as the pilot monitoring and the second in command acted as the pilot flying. When the aircraft was cruising, there were 3 master caution activations associated with the rudder travel limiter unit malfunction between 2301 and 2313. The pilots performed the ECM actions and the system returned to function normally. At 2315, the 4th master caution of RTLU malfunction was recorded, but this time the recorder did not record ECM action. At 2316, 5th master caution of the FAC1 getting faulty was followed by the 6th master caution of both the FACs getting faulty, resulting in the autopilot and the auto thrust getting disengaged. Next slide, please. In absence of the autopilot, the rudder got deflected by 2 degrees, resulting in a roll rate of 6 degrees per second to the left, and without the pilot input for 9 seconds, the aircraft banked 54 degrees. The second in command responded overcorrecting and giving a pitching up input from his side stick. The aircraft stall warning got activated and continued till the end of the recording. At 2317, the pilot in command's side stick input got initiated, but there were variations between the 2 side stick inputs. At 23:18, the aircraft disappeared from Jakarta radar control screen. Next slide, please. Later on, it was discovered that the aircraft crashed into the Java Sea with no survivors. Post-investigation following were found to be the reasons behind this crash. Next slide, please. The cracking of the solder joints in the electronic modules of the RTLU, both channels, resulted in loss of electrical continuity and led to RTLU malfunction. Next slide, please. So I cannot. Next slide, please. One of the major reasons were the inadequate maintenance processes, which resulted in non-identifying of this exact reason. It also included that the operator maintenance system had not mandated that the pilots to report their defects post-flight. The repetitive defects of the PFR, if corrected, were not reported on the maintenance records, and maintenance action without the maintenance record references were not recorded. Even with 23 occurrences of the RTLU fault within a duration of 1 year, the issue was not investigated and corrected thoroughly. Next slide, please. Following the fourth fault, the FDR had recorded signatures similar to the FAC circuit breaker being reset, resulting in electrical interruption to FAC, which caused the autopilot to disengage. Next slide, please. The startled reflex of the spatially disoriented second-in-command, the pitch-up input, and the lack of coordination between the pilots led the aircraft departing from the normal flight envelope and entering prolonged upset stall condition. And moreover, the pilots were not trained for upset recovery. Next slide, please. What changed were all towards the safety actions. Most importantly, the human factor training was brought into focus, especially the critical incident, stress management, psychological training, and upset recovery training. The maintenance procedures, roger that, procedures were relooked into. Aircraft custodians were earmarked for defect monitoring, and most importantly, all the fault data were now made available for the technicians. The SOPs and the policies by the aircraft operator, DGCA, and aircraft manufacturers were revamped. And the upset recovery and stall recovery training of pilots was mandated and carried out in a time-bound manner. Next slide, please. I have finished, sir. I'll be happy to answer any questions.
Okay. Thank
right.
you so much for keeping the time. Go ahead, Aashman.
All right. So in this crash, there were because of the faulty RTLU, there were 3 warnings, and they reset the flight augmentation computer. So when the 4th time the warning came, the pilot got irritated and he decided to leave his seat and reset the circuit breakers. So this kind of procedure is not there at that time. It was not there in any of the manuals. So why what did the pilot expect that resetting the circuit breakers would do to this problem? And what were the implications of doing this?
Sir, as already mentioned in the during the presentation, this RTLU fault was a recurring fault, and with the same pilot, with the same equipment, when the pilot was trying for takeoff 3 days before, the same fault came up during the taking off, and the flight didn't take off, and it was brought to the service bay. When the pilots were there in the aircraft, the service engineer came inside the cockpit. He first reset, and after resetting, the RTLU fault was not corrected. Then he carried out resetting of the circuit breakers. Post this, which the pilot asked the engineer, can I also do it the same? He told this can be done knowing the consequences, but he did not confirm everything. However, during that flight, even after resetting the circuit breaker, the RTLU fault was not corrected completely. So this can be taken as point that the pilot carried away with him that resetting the circuit breaker may correct the issue. And with respect to your second question, what happened after once the circuit breakers were reset? The circuit breaker being reset caused the both the FACs to de-energize. And this de-energization led in the power interruption to the FACs. However, after some point of time, the FACs were energized, but since they were not reset, they didn't got activated.
All right, I'll take that answer and move on to the next question. So again, a similar question to one of the previous crashes, that the plane eventually stalled, and the pilots are trained to handle a stall. So why were these pilots not able to recover from this stall? And also in particular, I want to ask that what was the one particular command from the captain to the first officer which further confused the first officer and acted as a significant contributor to the pilots not being able to recover from the stall?
Okay, so Major Surendra Kumar, I will request you not to answer the question. There are other team members. Ashish Chogle, can you answer? Ashish Chogle, are you there?
Yes, sir.
Yeah. Can you answer this question?
Yeah.
If no, say no, then we can go to somebody else.
Sir, could you brief the question like once again?
No, you are supposed to be listening, Ashish. You are supposed to be listening. So if you can't answer, forget it. Akash Yadav, can you answer? Kartikeya Chandra, can you answer? Baji Babu Komara, can you answer?
Yes, sir, I can answer. Sir, if possible, is it possible to repeat a question? I'm listening, but
All right, I'll brief you about the question once again. So, why were the pilots not able to recover from the stall? This is the first part of the question. And second is, what particular, like one particular command from the captain to the first officer confused the first officer further. In addition to being spatially disoriented, this led to further worsening of the stall and acted as a contributing factor due to which they were not able to recover. So, what was that command?
Okay, and 1 minute. Now, Ashish Chogle, have you heard the question?
Yes, sir.
Can you answer?
Sir, actually, because of the autopilot reset, the rudder was shifted to 2 degrees. So it made the flight like out of control, and he gave some roll command, and which brought the aircraft to 54 degrees roll. So it was not possible to bring it out of the stall at that place, sir. That's the first part of that question, sir.
Okay, okay. Second part, Baji Babu Kamara, can you answer?
Hello, am I audible?
Yeah.
Hello.
Yes, you are audible. Answer.
Hello.
We can hear you. Can you answer?
Hello.
Okay, I think we can go to Kartikeya Chandra. Okay, maybe Akash Yadav can answer. Okay, then maybe anybody can answer from the team.
Sir, for the first answer, the pilots were not trained for. Can you hear me, sir?
Yeah, we can hear you.
The pilots were not trained for upset recovery of A320, this particular aircraft. This was claimed by the operator as well as the company that the aircraft will not get into an upset conditions. And the second question was, what were the pilot in command to the second in command? Earlier, he started giving the commands of level, and later on, he started giving command of nose down.
So that is what caused the confusion.
Yes.
Okay. Ashman, do you want to go ahead? Any other questions?
No, these are the two questions I had.
Okay, fine. So, a request to all the students, kindly listen carefully to what is being discussed, because this is a team presentation. This is not an individual presentation that one person from the class can simply make a presentation. You cannot outsource your assignment to one person. The next will be team number 9. Team number 9, can you go ahead, please?
Hello, sir. We are ready.
Number 9. Which is the accident? Is it British Airways flight 609?
Sir, second crash investigation. Ethiopian Airline flight 302, Boeing 737.
Okay. I have to search for it. Okay. Flight number 15. Ethiopian Airline flight 302. Okay. Give me a minute. I will share the screen. And okay. Ethiopian Airline flight 302.
Yes, sir. This one.
Okay. Okay. This is quite recent. Last year.
Yes, sir. 2019.
Just last year, March. Okay. Oh, Max. Okay. I know. This is that Boeing Max. Okay. So 1 minute. I think I've got stuck into something. So no, this is not the one. Sorry. Yeah, 1 minute. This is not the one. Okay. There is some background noise coming from your side, so be very careful.
Okay.
If possible, you can just quieten the background noise if possible. Ethiopian Airlines flight number 302. Right, there you go. You can start now whenever.
Good morning, everyone. I'm Aman. I will be presenting the second crash PPT on behalf of Team 9. The second air crash investigation is on Ethiopian flight 302. The airplane in this flight was of Boeing 737 MAX 8 model. Next slide. In this PPT, we will be covering the following contents. Next slide. The Ethiopian airline flight was an international flight scheduled on 10th March 2019 from Ethiopia to Kenya. It was crashed shortly 6 minutes after the takeoff. There were no survivors among the 157 occupants. Next slide, please. Here are the sequence of events that happened. ATC issued the takeoff clearance. After the takeoff, the angle of attack deviation of 59 degrees was found between left and right angle of attack sensors. After this, the captain commanded the autopilot, but it got disengaged after 33 seconds. Captain announced that they are having flight control problem and wanted a return control vector, which ATC approved. Due to the angle of attack deviation, an aircraft nose down movement was activated by MCAS system and climb was arrested, and it got descended. The nose down deviation happened thrice during this event, and pilot tries to recover it, causing it to form the pitching oscillation of the aircraft. Next slide, please. Next slide, please, sir. Sir, the captain asked the first officer to trim up with him, but the trim was not working. So captain asked him to trim up manually, but due to large aerodynamic forces, it also failed. There was an automatic nose down deviation, which increased to 40-degree angle, causing the aircraft to plunge on the ground at a speed of 700 miles per hour. Next slide. Due to the flight software control problem, this aircraft was grounded worldwide. Over to you, Nipin.
So coming to the analysis part, team found that left-hand AOA sensor was faulty. Now ADIRU takes AOA value as an input to compute mark, CS and altitude correct as values. FCC also takes AOA values as an input to trigger MCAS and its duration. Next. Boeing 737 8MAX fleet was incorporated with maneuvering characteristic augmentation system. So to remain in business, Boeing increased the fuel efficiency by putting a larger engine. So they needed it to shift ahead and it a bit upward. So because of this, there was a nose-up tendency during high AOA flight. So to counteract this, MCAS was installed to give trim stabilizer command to make the aircraft nose down. Next. Coming to the working of MCAS, from the figure you can see AOA sensor and pitot probe gives input signal to ADIRU units, which then gives corrected AOA inputs to FCC. Now if AOA is high, MCAS would give command to stabilizer trim motor to actuate the horizontal stabilizer so that aircraft can make a nose down moment. Next. Team also found that MCAS was also fault. So left-hand AOA sensor showed high value and the flaps were present at 0 position during the flight. So this made fulfillment criteria for the MCAS to activate and they gave command to stabilizer trim motor. Now pilot at the same end also gave electric step trim command. So this took as a reset point by the MCAS and it created a loop for it to work. Next. From the graph, you can see highlighted portion tells left-hand AOA sensor showed high values compared to right-hand side. Next. Coming to few improvements and reasoning, FCC was not having any logic to identify erroneous AOA value. So FCC software was updated to eliminate the complete reliance of MCAS on single AOA signal. Then MCAS was generating repeating commands. So controls law was changed such that MCAS will be activated only once per high AOA value. Then MCAS stream authority was working in incremental mode, independent of position of
30
stabilizer.
seconds left.
Roger. Flight controls law changed such that elevator movement is reserved for pinch control by the pilot. The flight crew were not effectively managing the stabilizer movement because of lack of MCAS training. So revision and provide additional training was done by Boeing to tackle this scenario. AOA disagree alert message was not functional. So Boeing implemented that it will be displayed in the aircraft. Other FCC stabilizer failures were looked upon, and it cross monitoring of FCC was required to detect erroneous commands. Next.
Time's up. Please stop.
Yeah, thank you. That's it.
All right, should I start?
Yes, please. Please
Yeah.
start.
So there was one more crash regarding a similar malfunction in the MCAS unit just a few months before this accident. So could you just name the crash?
One minute. Lokesh Gudavalli, can you answer? Lokesh is not there. I think. Okay, then let me ask Arush Bilaya. Arush is also not there. Okay. What about Sagnik Banik?
Yes, sir.
Answer.
Sir, the accident was Lion Air 610. It occurred in October 29, 2018, and the plane took off from Jakarta, Indonesia, and the plane
All right,
crashed
that's
in
sufficient.
Davos.
That's sufficient. My second question is that it was mentioned in your PPT that the pilots were not trained properly to handle any fluctuations or malfunctions that could occur in the MCAS system. So why were the pilots not trained properly for this system?
So this can be answered by coordinator Atul Kumar Mathuri.
Yes, sir. Sir, the reason to this is very basic, sir. In this, the Boeing has upgraded for the efficiency of aircraft. They have changed the engine, and they had shifted the position. However, they did not want to invest on the training of the captain or anything, so they introduced AMCAS system. However, they said the no additional training on the pilot is required, and they did not go ahead for any formal training part. However, they had introduced a normal bulletin that there is a technical bulletin that says that MCAS is a part of the aircraft, whereas no practical training of the pilots was given. Hence, they were not aware in what scenarios the MCAS can malfunction and what are the recovery procedures.
May I interrupt and ask that why were they not given any practical training?
Sir, am I clear?
Yeah, you're
Hello.
audible, but
You're audible.
You have to answer exactly what he's saying. Why were they not given the training?
Sir, this was the reason, sir, where the Boeing had claimed that no additional training on 737 MAX 8 will be required for pilots to operate it. So they had just introduced the software, whereas they had not given any formal training. That was the major reason there was no training part was introduced for air crews across the globe.
All right, I'll take that and move on to the next question. As mentioned in the sequence of events, the MCAS activated once, due to which the nose dropped. Okay. After that, the pilots were able to regain some control and they managed the nose from pitching down further. But a short while after that, the MCAS activated again, due to which the nose dropped down further. At that point of time, the pilots flipped a pair of switches to disable the electrical trim tab system. So what were the implications of disabling the electrical trim tab system, and how did it lead the plane to crash?
Okay, so Saran here. Can I answer this?
Yeah, you go ahead.
Yeah, okay. So when they switched off the electrical trim tab switch, so what happened was they also disabled MCAS with it. But whenever we are disabling the electric trim tab system, then we have to apply the force manually to turn the stabilizer trim. So with the stabilizer trim at a particular angle such that the aerodynamic forces were high, they weren't able to manually, what is it, that trim the stabilizer trim. They weren't able to manually change the angle because there was a load of around 90 pounds on this horizontal stabilizer.
So is that it from your side? You want to add anything?
Yeah, that was it.
All right. So these were all the questions I had.
Okay. All right. Let's go ahead then. The next team will be team number 1. Team number 1, are you ready?
Yes, sir.
Okay. So team number 1, I have actually, there was a request, I think, to remove the animations, correct?
Okay, sir.
So who is going to present?
Sir, Mayank Prakash.
And which question, which will be specific airline?
Sir, Trigana Air 267.
Okay. So, Trigana Air Flight 267. Okay, just a minute, please. Trigana Air Flight 267. Right. Go ahead. Go ahead. You can start. You can start.
Okay. Good morning. For Team 1, I am presenting the crash of Trigana Air 267. This accident took place on 16th August 2015. It is a scheduled passenger flight to Oxybil, a twin ATR 42-300, killing all 54 people on board. The next slide. Okay. This is the scope of presentation as flashed. Okay. It's okay. This was the 5th flight of the day and the 2nd flight on the same route for the pilots. The chain of events started in the previous flight in which the pilot took the shorter approach, you can see in the marked as yellow, rather than the approved route as marked white with visual approach. While landing, GPWS gave erroneous warning, so the pilot shut it off as a shut it off. Okay. In next slide, please. This picture despises the summary of the flight as recorded from CVR. We can see in that on the fatal flight, pilot tried to mimic the same approach, but this time the visibility was low due to the low cloud cover. Still, they proceeded with visual approach with no visual flight reference, and the plane crashed at 8,300 feet on the mountains near Oxybil. Next slide, sir. As you can see, the plane directly hit the mountain. The debris area was small and burned by this post-impact fire. FDR, the flight data recorder, and cockpit voice recorder were recovered by investigation team. However, flight data recovered was inoperable due to poor maintenance. Next slide, sir. So when the pilots were able to land previously, what went wrong this time? These were the factors as mentioned by KNKT. First, the low visibility due to low laying of clouds, and the wish of pilot to continue the visual approach without any visual flight reference, and the wrongly mentioned minimum descent altitude were the main reason. Other reason was that the GPWS, the ground proximity warning sensor, was turned off in the previous flight, which was never turned on, suggesting the negligence of checklist briefing on the normal operation of flight. Another reason also KNKT inferred that the short trips with frequent takeoff and landing among the unnecessary warning caused the fatigue to pilots. Next slide, sir.
Yeah.
So this is what you are seeing is an approach chart. You can see that the mentioned mentioned incorrect minimum descent altitude of 8,000 feet. While in the direction approach, while the height at which the flight crashed was 8,300 feet. Next slide, sir. So here is the sectional view of the flight path along with the several key points of GPWS warning. As you can see that the gray line was incorrect minimum safe descent altitude, and the height of the mountain was way above it, which is a major factor in causing the crash. Next slide, sir. So this was a little GPWS joke for you. Next slide, sir.
Yeah, let me just tell you that this is a joke on GPWS, but the example is TCAS.
Yes, actually TCAS mentioned the first plane to descend, but GPSW was not activated, so it just crashed in the mountains. That was a major thing of this slide. Okay. So as mentioned, GPSWS is an instrument to warn the pilots for the as when they are close to ground an obstacle. As you can
30
see,
seconds left.
okay, as you can see in the image, there are the various layers of imaginary surface in the obstacle in the red and orange color. Next slide, sir.
Not you don't have to say okay. You have to say Roger. That is the correct aeronautical language.
Okay, Roger. Next slide, sir. So you can skip this.
Terrain. Pull up. Pull up.
So these were the main point lesson learned. First, the better referencing was done for terrain, and KNKT also encouraged to reduce the
Please stop. Time's up.
Okay, so it's okay. They are late, but we can give them some another 5-10 seconds to finish up. Is there anything else you want to say about lessons learned?
Yes, sir, that was the only slide. Okay.
Yeah, what is the lesson learned? Quickly tell.
So the lesson one learned was that the ranging of the terrain was incorrect. So that made the GPWS unreliable. Another issue was that the fatigue to the pilots was another issue, where as the takeoff and landing create much strain on the pilot.
Okay.
Another thing was the visual guidance.
It's okay. Even everybody is giving you a warning, not only yes. Okay, guys. No failure is in vain. That's it. Thank you. Aashman, start the questioning now, please.
Yeah. So since this crash happened around evening, so like what is the this question? A similar question I had posted while asking I asked a similar question for the Tenerife crash, that what kind of a geography is this airport located in, due to which weather becomes a problem during the evening time?
Yeah, I think. Can I answer this? Or, I think anybody this? This was a mountainous terrain, and this the geography itself, there was cloud formation and all is a regular phenomena there. So that is the reason there that cloud was there, and because of the wrong terrain mapping, it was showing a different height. This crash basically took place.
You have to answer the question very specifically. If you don't know the answer, you say I don't know the answer, because you are wasting your time. Okay, Aashman, I think they have not answered what you have asked.
Yeah.
Let's go to the next question.
Okay.
Can I answer this question?
Yeah, if you want to answer specifically. Otherwise, there is negative marking. Yeah.
This terrain contained a lush jungle, so it is very humid and very favorable to cloud formation.
No, the question is not about the terrain. It's about the airport. The question is about the airport, not about the terrain. Anyway, let's go ahead. Next question. We don't have time. Yeah.
Yeah. So, the pilots were informed that there was a cloud cover at around 8,000 feet. So why did they crash above the cloud cover? Why did they not have the updated information regarding the latest weather controls? Weather details, sorry.
Sir, I would like to answer this question. Aditya.
Go ahead.
So, actually, the ATC mentioned the pilots that the cloud cover was 8,000 feet, and in the approach chart, the pilots got that the safe descent altitude was also 8,000 feet. Like if they were above 8,000 feet, they were safe. So, as the cloud base is at 8,000 feet, the pilots thought that as long as we are in the cloud base, which will be above 8,000 feet, they were in the correct altitude, and so there was no chance of crashing. But the mountain which they were crashed was at a height of 8,300 feet. So they went straight and hit the mountain head on. So that it was due to the improper approach chart which was available for the pilots for the visual approach landing.
Okay, next one. Next question, Aashman. Okay, I think there is some problem on Aashman's side. Let me just go back. Just give me a minute. Okay. I think we can move on to team number 6 now. Team number 6.
Sir, am I audible? Devashish here.
Devashish, you are audible. So you are going to talk about which accident?
Sir, ASA 2311, first slide, sir.
ASA 2311 accident. Okay. So, right. Yeah. All right. Let's go ahead.
May I start, sir?
Yeah, please start.
Jai Hind, everyone. Group 6 presenting air crash investigation of Atlantic Southwest Airline Flight 2311 happened on 5th April 91. Next slide. Aircraft involved was Embraer EMB 120 of ASA going from Atlanta to Brunswick with 23 on board, all fatal. No severe and FDR on board as it was not required as per air regulation at that time. Next slide. Flight departed Atlanta at 1347 and cleared for landing at 1448. After undercarriage down and speed reduction, aircraft started rolling towards the port side. With increase in RPM of left engine, captain tried to recover, but at 1000 feet AGL, aircraft rode completely to left with wing at 90 degree to ground. Aircraft crashed with nose down impact. Next slide. Aircraft was fitted with Hamilton standard 14 RF9 propeller. Analysis revealed that the reason was a loss of control due to loss of lift on the left wing. Left wing propeller blades were found to be at 3 degree against the commanded position of 79 degree, which is a feathered position. A feathered position is a position in which blades edges are to be facing to the wind and offers minimum drag. At 3 degree, the blades acted like a flat plate, blocking the normal airflow and hence de-energizing flow over the left wing, which resulted in high drag, reduced thrust, and reduced lift on the left wing. The asymmetric thrust caused the aircraft to yaw towards left. This created an effect similar to adverse aileron yaw, resulting in progressive rolling of aircraft towards left till wings become perpendicular to ground in absence of any anti-rudder action. Next slide. Findings brought out that the teeth of the quill, which is a part linking propeller control unit and blade moving assembly, through the transfer tube were totally worn out. The link was broken at the point mentioned by the blue arrow in the figure. Recently, the manufacturer has changed the coating material of transfer tube and used a harder material, titanium nitride, to improve manufacturing efficiency. This harder coating acted like a sandpaper or a giant file and worn out the teeth of the quill. As the teeth of the quill worn out, the blades were free to move. However, as per manufacturer, they have included a fail-safe mechanism to move blades to the feathering position if quill disengages. But the fail-safe mechanism was certified only on the basis of results achieved in the ground testing, not on the actual flight test. As it was a mechanical failure, pilots don't have any control. The coating material change is a minor change classified by FAA and can be done by manufacturer without prior approval of Federal Aviation Administration. Next slide. The NTSB recommendations for changes in the industries were: first change was the review of certificate of Hamilton standard propellers, which resulted in removal of titanium nitride surface transfer tube. Similar checks were also ordered for other turboprops in USA. The fail-safe features to be certified for failure modes in real condition. That is, to take in consideration aerodynamic load in flight, high vibration, and the turbulence which is likely to occur in the flight. The transfer tube is supplying servo ball and other propeller control unit parts, which were supposed to handle the low torque and are made of cast material, which is supposed to be very reliable. Hence, the periodic inspection was not included originally. However, NTSB included a servicing check at 900-hour flight after this accident. Recent change in reduction in rest period of pilots was also removed for ASA. Next slide. Learnings. The crash occurred due to wearing out of rotating components due to improper coating. This highlights the impact of trivial issues such as coating material on flight safety. Second, fail-safe mechanism to be, though present, not tested for actual conditions, proved to be of no use when it was supposed to perform. Third, maintenance philosophy and schedules to be carefully designed to include periodic inspection of components that may have wear and tear. Last, certification of minor changes is a critical function, and hence, certification of minor changes.
Please stop.
Sir, it is finished. Minor changes are certified by ALTIMETER testing. Next slide. These are references.
Yeah, I think time is up anyway.
Sir, we are finished.
Yeah, so time is up. Thank you. I think we can go to Aashman for his questions.
Yeah, I'm audible, right?
Yes, audible.
Yes, sir.
Fine. So to be honest, you covered pretty much everything about this crash. Just one thing I want to ask is during the investigation, this investigation was solely done and solely carried out on basis of inspection of the wreckage and whatever was left of the plane. So why was this inspection performed in such a way?
So because there was
Oh, wait a minute. Can somebody else answer? The person who speaks is not necessarily the person who's supposed to answer. Anybody else in the team can answer? This is a team assignment. Is there nobody else from the team present?
Sir, this is Rahul Anand, sir.
Yeah, Rahul, go ahead.
So, sir, the investigation was done based on the wreckage because mainly it was a mechanical failure. So the wreckage was able to reveal the mechanical aspects because it is a wearing out. So
I understand that it was a mechanical aspect.
No. You have to be very specific in this answer.
So
there is a very specific reason why the investigation was done purely on the wreckage. There is a specific reason, and that reason is important. So
Hello,
Yes.
sir. Sir,
Yes,
this is Sunil. Sir, there is no lot of budget for the FDR and CVR, so they don't go to this.
Okay, right. That is the correct answer. There is nothing else available. In a normal aircraft, you have an FDR and a CVR, but here there was no FDR. So therefore, the only way to investigate the accident is after the accident, the wreckage. Okay, Aashman, next question.
So I don't have any more questions. To be honest, they've covered everything.
Yeah, I think they have covered everything. So now the last thing is the last team, that is team number 2. Team number 2, over to you.
This is Pacific Southwest, right?
Team number 2.
Yes, sir. This is Major Rahul Nodial, sir. Southern Airways Flight 242.
Okay, I'm trying to just locate your presentation. Southern Airways Flight 242. Okay.
Right, sir.
Right. So Rahul Nodial is going to present on it. So